The King of the Hill triathlon race in Kinsale consists of a 750-metre swim followed by a 20-kilometre cycle followed by a 5-kilometre run. The questions below are based on data from 224 athletes who completed this triathlon in 2010. Maura is analysing data from the race using statistical software. She has a data file with each competitor's time for each part of the race, along with various other details of the competitors. Maura gets the software to produce some summary statistics, and it produces the following table. 3 of the entries in the table have been removed and replaced with question marks. Maura produces histograms of the times for the 3 events. Here are the 3 histograms without their titles. Use the summary statistics in the table to decide which histogram corresponds to each event. Let's look at the mean of these distributions. We know that the mean is the balance point of a distribution. So if we imagine that we're balancing all of these rectangles on this line here, the balance point for this particular histogram is approximately here, somewhere between 24 and 26. So we have the means of 2 distributions stated here in this table. So it appears that this distribution is for the run. Let's look at the next distribution. The mean or balance point of this distribution appears to be between 40 and 44. And we see in the table the mean for the cycle is 41.927, so this distribution appears to be for the cycle. Finally, this one here has a mean that looks like it is somewhere between 18 and 20, and we see from the table the mean for the swim is 18.329. So this must be the run. The mean and the median time for the run are approximately equal. Estimate this value from the corresponding histogram. Well, the median is perhaps easier to get from a histogram. The median is the point that halves the area of the histogram. So the median time is a point such that the area under the histogram to the left of the median time is half the area under the entire histogram. Now, from this histogram, the median looks like it's between 24 and 26. This value here is 26. 26 is certainly too big. The area to the left of 26 is greater than the area under the histogram to the right of 26. 24 is certainly too small. The area under the histogram to the left of 24 is less than the area under the histogram to the right of 24. So it appears that the median is somewhere between 24 and 26. We could say that the median is 25. That's accurate enough based on this histogram. The times, by the way, are in minutes. Now we can see that the distribution for the run is roughly symmetrical. If that's the case, the median is approximately equal to the mean. So the median is 25, so the area, this shaded area, is half the total area under the histogram, roughly half. And it's about equal to the mean, so it's about equal to where the balance point is. The balance point would also be at around 25 minutes. Estimate the standard deviation of the times for the swim. We see that for the swim the variance is given, and it's a fact that the standard deviation is the square root of the variance. The variance is just another measure of spread or dispersion. We just need to get the square root of 10.017. To 3 decimal places we get 3.165 minutes. If we weren't given the variance for this histogram, we could use the histogram to calculate the standard deviation. We would have to take mid-interval values for each interval, use those values for the times, and the height of each bar is the frequency. And from the values and the frequencies, we could calculate the standard deviation, but that would take quite a lot of work trying to read off the heights of each bars from this diagram. So if you're given the variance, just get the square root. When calculating the summary statistics, the software failed to find a mode for the data sets. Why do you think this is? we can see for mode we just have not applicable. The mode is the value that occurs with greatest frequency. Suppose we look at the times for the swim. If there was a mode, it would be a particular time, or maybe more than one time, which occurs more often than other times. But you see, the times for the swim are given to 3 decimal places, just as the times for cycle and run are. So it's highly unlikely that we're going to get more than one value that has the same time, or I should say a repeated value that has the same time. It's highly unlikely, because we're dealing with thousands of a second here. Well, thousands of a minute actually, but it's still very small time interval. So it's extremely unlikely that, for example, we're going to get a time of 18.32 minutes for more than one person. So no one time appears more than once apparently, because we're dealing with thousands of a minute. If you want to see what that is in seconds, there's 60 seconds in a minute. 60 divided by 1,000. So we're talking about 0.06 of a second. So we would need a set of times to be within 600ths of a second of each other in order for us to consider that set of times as a modal time. 600ths of a second is so small in this context that it is unlikely that a modal time will appear.